I want to work one less problem about women's pulse rates in this lesson. Suppose I want to approach these problems in a different way. My interest is finding the pulse rate that will separate the highest 10% of women's pulse rates from the lower 90% of women's pulse rates. So I'm presenting this problem to you in sort of a reverse fashion. In our prior examples in this lesson, I gave you specific pulse rates and wanted to know what percent of the women's population were less than that or maybe greater than a particular pulse rate. Now I'm asking for a particular pulse rate that would separate the population in this exact way. 10% at the top, 90% at the bottom. So let's recall, if you're not in my online class and you're just joining us, that women's pulse rates in this example have a mean of 74 beats per minute and a standard deviation of 11.3 beats per minute. And we established that the distribution of pulse rates is normally distributed. So I've encouraged you to sketch your problems in this lesson. We're going to rely a lot on technology to do the more mathematical things, but it's important for us to visualize what we're trying to accomplish. So here's a sketch that I prepared. So you can see I have the normal model here, and in the middle I put under the peak, I put the mean, and then each of these tick marks is exactly one standard deviation apart. So you can see I'm adding and then subtracting in this direction 11.3 to give a nice clean sketch. Now I'm going to insert information that we found out, which was we want 10% on the top, 90% on the bottom. So I came in here and inserted that information, but I did it with a little bit of guidance from the empirical rule. So I wanted to draw a nice model to scale for you guys. So I remembered that 2.5% of the population is above 96.6, right? This little region right here that I haven't sort of to the right of this 10%. And also remembered from the empirical rule that 16% of the population is above 85.3. So when I wanted to insert 10% in there, I knew that it would fall somewhere between 85.3 and 96.6. So I just sort of sketched it in there, not necessarily measuring anything, but knowing that 10% to the top would be somewhere between 85.3 and 96.6. So let's take this, and again, my unknown quantity here is exactly what pulse rate would do that. So let's take this to software. I'm going to navigate to Stat, Calculators, Normal. Give us a normal calculator. We're going to set this up for women's pulse rates. It's StatCrunch is just waiting for a particular application of the normal model to be used. So we have a mean of 74, a standard deviation of 11.3. And typically, I would put in a pulse rate and wait for a probability or that would turn into a percentage, and we would begin to speak about pulse rates in this way. Now, notice here, it actually says that there, probability, a number between 0 and 1. This is where you type in the information that was given. 10%, which I turned into 0.10. StatCrunch will not let you input a percent into it, so I gave it its decimal equivalent, the number between 0 and 1. And also I remember that it told me the top 10%, so I want to make this greater than. So when I do that, let me click the empirical rule tick marks. I can see here that that's exactly what I sketched on my prior slide. 10% to the top in red, this white region is 90%. And if we want to check out the pulse rate that'll do that, here it is, it's highlighted in blue. That's 88.5 beats per minute. And that kind of makes sense if we think about it, that is the solution. We talked about how this answer would be between this tick mark and the second tick mark from the right. Let's go back and put it in the model. Finish out our sketch. So here we are, that's the sketch we had earlier, that we had before we went to technology. And now we know through the use of this normal calculator that that's 88.5 beats per minute is the pulse rate that would separate the top 10% of the population.